guys and gals. Hey guys and gals, how you doing? How are you doing today, this fine day? I appreciate you hitting that play button. I appreciate you. Let's go. Thank you for being here. Thank you for being here. Let's go, learning and growing. You guys are all awesome, beautiful, intelligent people. I appreciate you all. Let's go. Time to turn it up. Time to turn it up. Okay, so I'm gonna quickly just want to check things before we get going. Let's go. All right, nice. Welcome, everybody. Homeschooling children. Welcome. This is for you parents homeschooling your kids. Here to support you in your decision. Here to help. And I'm going to do my best to help you out. Also, students, you're welcome here as well. It's great to have you all. Truly is. Thank you for watching, learning, and growing. Let's go. You guys, part of the 120 plus IQ club. Let's go. All right. We shall continue. Let's get to work. We are working on Unit 1. Now, last video was definitions and such. The unit is called pricing and currency exchange. But within that is also ratio and proportion, guys and gals. So we're going to be learning a few different things here. Really no less straight lesson plan, just kind of following a little pamphlet and just kind of working through problems. So it's great to have you, and flick that old switch in the mind, and let's get to learning. Okay. So last we were talking about, I wonder if I could actually redo that. Will it let me, or is it undo? No. Or is it undo? Maybe it is. No, it's not that. Okay, never mind. I thought I could undo, but that's okay. I'll just write it again. We were working on a random number here, and we were talking about position and value placement, I guess, within a series of numbers with a decimal. So this is the ones. We'll kind of quickly go over it, and then we'll continue. Ones, tens, ones, tens, hundreds, and thousands. Okay, ones, tens, hundreds, thousands. Of course, this is the decimal. And then there's no such thing, so to the right of the decimal, guys and gals, there's no such thing as once, okay? It's not even a word, and it's kind of, I don't know. It's a little bit tricky to even say, to be honest. But it goes from this first digit is the tenths place. Basically, it's the same thing, except instead of saying tens, it's tenths with a TH, okay? Tenths, and it's the same thing. From tenths, it's hundreds, trying to write it out kind of neatly for you here. Hundredths. Ugh. And lastly, thousandths. And of course it continues the same, right guys? I just thought I would kind of redo that for you guys and gals in case, you know, there's a little bit confusion last videos. Thousandths, and again, it's a TH ending, okay? All right, makes sense? I hope so. And it continues the same, ones, tens, hundreds, thousands, 10,000s, right? If we had a number here, this would be 10,000ths, right? And then it continues, okay? Now, I don't think I have, I don't know, I didn't really search for anything on the internet to show, just as a good visual, but hopefully you get the idea. Now, in regards to rounding, you're really going to be only rounding to maybe the nearest tenths or the nearest tenths. Just depends on what the answer wants you to round to. Rounding rules, if you're rounding to the nearest tenths, because this is greater than 5, you would round up. Okay, so this would become a 3. As an example. Okay. So let's do this. We'll just do a couple examples. Trying to get back into the teaching mode here, guys and gals, so bear with me. All right. The number 37.02. So round to the nearest, well, tens, okay? Nearest tens. Oh, my penmanship with a mouse is terrible. I wish I had a tablet. This would be so much better. It's not something I really practice doing, right? Okay, 10. So basically, so again, remember, right? Anything to the right is the stuff. Except it's not thus, it's tens. So ones, tens. So that means we're rounding to this position. So because 7 is greater than 5, right? 7 is greater than 5, we round up. Okay? So essentially it's going to end up being 40. If we're to continue the accuracy, 40.00. Okay, let's do another one. Continue. 6.84. Okay, round to the nearest tenths. Okay. So again, the this is to the right to the decimal, right? And remember, there's no such thing as once, right? Remember that. It's kind of key. So that means we're rounding to this position. That's tenths. So looking at the number beside it, which is 4, 4 is less than 5, therefore there's no rounding, so we end up with 6.84. Now, I have no way to check that answer, but 6.84. We could drop the 0 to actually, you know what? Come to think of it, that's really what it means. And I apologize for showing that extra 0. It's actually 6.8. That's rounding to the nearest tenths, right? You shouldn't be showing, because if me putting a 0 here, that means I'm rounding to the tenths, hundredths, right? Just to be clear, I kind of had to wake up on that. Going back to the, I don't know why all of a sudden it's just, yeah. Gotta shake my head, wake up here a little bit. Okay. 37.02. Okay, just to correct my little mistake here. Okay, rounding to the nearest tens, which is ones, tens. Our answer is actually going to be 40. Okay, I apologize for talking about the accuracy. I don't know what I was thinking for a second there. But that's rounding to the nearest tens. Okay. Dun, 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 and fixing things up. I don't know, just the first, yeah, anyways, I just gotta wake myself up here. Okay, let's do this one. 40.165. Okay, round to the nearest hundredths. Okay, so it's, I'll just write it, I guess. It's the this. Okay? When you see this, it's to the right. To the right of the decimal. Okay? So this is tenths. That means this position here. Okay? Which means we're dropping this, essentially. Okay? That's what's happening when we're talking about rounding. So to the nearest hundredths. So because the rule is if it's 5 or greater, if it's greater than 5 or equal to 5, I kind of wrote that wrong. It's kind of written like that. That means greater than equal to. If I didn't really have the room for right. If the number is greater than or equal to 5, okay, that's kind of how I wanted it. I was trying to show it to you so without confusing you. If the number to the left is greater than, okay, if the number here is greater than or equal to 5, the rule is round up. Okay, that's kind of what I'm trying to get at here. Okay, guys? Without confusing you. Okay, and you round up. Okay, so that means our answer is going to be 40.17. Just fixing, correcting it on here on my paperwork. Okay, try the following. Round to the place value indicated. Okay, let's do some other basic ones. Okay, we have 729. Just going to work on rounding a little bit. It says round to the nearest hundreds. Okay, hundreds. Ones, tens, hundreds. Okay, so we're going to look at this. This is all less than 50, right? So therefore, we're not really rounding up. So there's no rounding up. So rounding to the nearest hundreds would be 700. Okay, guys? Let's do another one quickly. 5.82. Okay, tenths. Thissa. Okay, tenths. Tenths is here. This 2 is less than 5. Therefore, no rounding. So our answer is going to be 5.8. Okay, there we go. That's the answer. $7.68. Again, we know the decimal's there, right? It's just a whole number. Tens. Okay, tens. Ones, tens. So we're rounding to there. 8 is greater than 5. Therefore, we're rounding up. Okay, so our answer is going to be 770. Okay. One-eighth in a fraction is 1/8. In decimal is 0.125. Must learn that. Round to the nearest hundredths. So this, round to the nearest hundredths. Hundredths. Tenths, hundredths. This position, 5 and greater, right? If the number is 5 or greater, I don't know the best way to write that, but the point is, if it's equal to 5 or greater, round up. That's really that's the rule. Okay? So our answer is going to be 0.13. All right. A couple more and we'll get on to something else. 48.6. Round to the nearest ones. Okay, that's right there. 6 is greater than 5. Therefore, we're rounding up. So 8 becomes 9. And that's rounding to the nearest ones. Okay, essentially we're dropping that. Last one, 6.249 tenths. Round to the nearest tenths. So here's tenths. This all gets dropped. Okay. So, I don't know, like for this, technically speaking, the 9 would round this to 5, and then the 5 would round this up. But I believe, I'm just trying to recall, I think we ignore this one. It's ignored, and then we just look at this digit. Because technically speaking, this could be rounded up. So, now, do I have the answer for that somewhere? I don't know. I don't think so. In math, rounding up typically means increasing a number to the next whole number when it's between two whole numbers. Blah 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 blah. What's the rule for 3 significant digits? For example, if we take the number 2.345 and want to round it to 1 decimal place, we would round 2.345. The formula would return 3. Yeah, see? Yeah. So I'm just kind of checking on the internet. They're saying that 2.345. It's been a minute, kind of did the rounding stuff, but to me it's just basic math stuff. Going over it again is kind of nice to refresh the mind too. Rounding to the nearest looks like tenths, it's saying. So the answer they're giving is 2.3. Okay. Let's see if I can find another example here, just so we can confirm this. 248. Let's see what they do with this one. 248.561. They're rounded to 2 decimal places. Well, this one's easy because it's obvious, right? If we're to round it to here, it would be 248.6. That's pretty obvious. If we're to round it to here, well, obviously it'd be 5/6. So that's an easy one. It's just, how does the rounding work when they're asking to this position when you have something like this, right? So with that last example, they went 2.3. So I'm going to go with their suggestion. I'm going to say 6.2. Just one of those little rules I kind of forgot. So anyways, I do this stuff because I don't worry too much. To me, it's just simple math, kind of mathematics stuff. Okay, quick drink of coffee. Alrighty, let's go. Now, if you want, you can confirm that with your instructor. But I believe that's it. Okay, the other ways are pretty straightforward, right? Let's continue. Order of operations. Okay, we're gonna do some bed mass, ped mass. Do I have that in here? No, I don't. Okay, it's all the same. Everybody kind of calls it bed mass or ped mass, however you want to look at it. Okay, it all oh jeez, I always get that weird leg spike when I'm writing. I don't know why. Okay, and of course this is all going to be the same, right? It all means the same thing. Brackets, parentheses, potatoes, potatoes, tomatoes, tomatoes. It's all the same. Okay? Just means brackets. Okay, so I always group these together. Just like this. So we have 1, 2, and 3. Because really that's what it is. If you have brackets, do the brackets. Sometimes you don't have exponents, right? Anything, really, when you're working with exponents, you're still working with brackets. Because, technically speaking, you have brackets and you have an exponent. You're kind of doing this anyways with the brackets. So, normally you would do, let's say, for example, you had, I don't know, 2 plus 5, and then the squared. You're going to want to do what's inside the brackets first, right? Which would give us 7, obviously. And if you have your times table memorized, you would know that 7 squared is the same as saying 7 times 7, which is equal to 49. These numbers here, you need to memorize these squares. They're called perfect squares. We're going to be getting into that shortly. Okay, guys? The perfect squares. 2 squared, 4. 3 squared, 9. Memorize those. 4 squared, 16. Okay, I'm just giving you a heads up on this, because we're going to be working with these quite a lot, and it's good to have these all memorized. So on top of memorizing your times table, again, you guys should be able to do the squared ones, right? It's no different than saying 2 times 2, 3 times 3, 4 times 4, 5 times 5, right? It's all the same. Recommend that you memorize those perfect squares. Okay, this is for you guys. You guys are the 120 and higher IQ club, okay? More intelligent than the rest. Okay? So, and then once you've done that, then anything outside the brackets, right? We would have ended up with 49. So if at this point, if you're multiplying or dividing, it could be division. Remember, division means fractions, guys. Anytime you see something weird like this, let's say it's divided by 7, I recommend, because you could end up with some more stuff. I don't know, maybe you end up with 5 plus 2 as well over here, right? I recommend when you solve these type of problems, put it in fraction form. Okay, this is a serious tip I'm giving you guys. You guys aren't going to get this anywhere else. People think they're so smart because they know how to use BEDMAS. Like, who cares? I could teach my cat BEDMAS and which order to do stuff. Who cares? You know how to use the sequence. Big deal. Everybody can learn the sequence. The problem is a lot of times people will go 49 divided by, if I didn't have these brackets here, I'm just going to erase it. I just want to give you a quick example, because I kind of chuckle at these guys that think they have the right answer, but they're actually wrong. They think they're right because they use BEDMAS, the sequence, properly, but that doesn't mean you got the right answer. So they'll go like this. They'll actually do this. That's how you get the wrong answer. That's my point here, guys. This is my point. Division equals fraction. You see the difference in result for your answer? You guys are getting some good tips here. Okay? So they would have went 49 divided by 5, which gives you some weird, I don't know, decimal value. Right? What's the closest we're going to get? 5 times 6, 7. 5 times 7, 8. 5 times 8 is 40. 5 times 9, 45. 4. I would borrow a 0, right? Get 9.8, right? Is that what it works out to? Hopefully I can math. I don't know why I need to dump a bucket of water on my head today, guys. Look at that. I actually even know how to do that. Crazy. Must know what I'm doing. So their answer would have been 9.8 plus 2, right? This is the incorrect answer. I'm trying to show you. 9, that's 11. So they would have had 11.8 for an answer. In a decimal value, when in fact it's 7. 2 different answers. Okay, that's my point. Like that, this is the linear thinkers, right? They're very linear thinkers, right? They're not thinking outside the box. Okay, thinking outside the box. This is a fraction. Okay, you guys. Again, I have the brackets here, so it's pretty clear. But let's say the brackets weren't there. Okay? It's a fraction, guys. Don't sleep in fractions, class. That's what I'm saying. I don't know why people can't see that. Division equals fraction. I'm going 1 divide by 2. Right? 1 divided by 2. That's the same thing as saying the word division. Crazy, huh? Now, I'm not making fun of you guys. It's just, you guys are awesome, okay? I just want you to know. I'm not making fun towards you. So, just to be clear. Just for those other people that argue up and down. I got the right answer. You're wrong. No, you're wrong. Okay, the little tip there. That's algebra stuff right there. Which we're kind of doing right now. This is technically speaking algebra that we're doing. Okay. This leads into it. It's no different. We could have x times 4 here. We could, right? And let's say we knew x was equal to 8. Then we'd just be substituting, right? It's all the same, okay? This is just kind of leading into it. So you guys get practice doing this. So we have minus 16 times 2. Okay? So here's my tip. Anytime you see subtraction, just you know bed math, right? Brackets, exponents, division, multiplication, addition, subtraction. Subtraction. You know that's the very last thing you're going to be doing because it's subtraction, right? So look at this as kind of like the fence. You have neighbors. This is neighbor 1, and this is neighbor 2. Okay? It's kind of the simplest way I could kind of explain it to you guys. So this is neighbor number 2, and this is neighbor number 1. Okay? Pretend this is the fence. So really what you're doing is you're working with the left side here first, and you could work on the right side. You could actually do them both at the same time, because the subtraction separates both equations. I'm not trying to confuse you here, but yeah, just pretend this is a fence, okay? They're two separate parts. So you could actually, my point is you could do this and you could do this separately of each other. Think of this as neighbor 1, think of this as neighbor 2. Okay, I'm gonna clean this up so you can see. Alright, so this is times, like they had an X here, but I'll use a dot, that's fine. A dot is multiply for me, okay? Or I could use an asterisk, but it's kind of a little bit of a pain to draw. Okay, so if you see a dot, that means multiply. Alright, so again, this is this is neighbor 1, neighbor 2. I could do both of them at the same time. Again, remember, addition, subtraction is still last, right? So, knowing your times table, you know that 8 times 4 is 32. I love this stuff. This stuff, as soon as I realized I could do algebra, like 2a plus 2a, this is a basic, easy one. As soon as I knew I could do this and I was advancing my algebra, like I went, wow, I could do this. I actually have a brain. And yeah, I just went for it. I dove right in and I did so many algebra problems because once it clicked, man, I loved it. I just wanted to do more and more and more and more. So let's just say I've had lots of practice, okay? 16 times 2. I could do the long work if you want to see it. It doesn't hurt to practice it. Plus, you should be able to do the mental math in your head. You know, 6 and 6 is 12 without even having to multiply. You could just add 6 and 6 together. And then you know you're going 2 times 1 is 2 plus, right? You know 15 and 15 is 30, right? You can think of this as a mental math thing. And you know that you have 2 16s, right? So there's an extra one here and an extra one here. That's where the 2 comes from, right? Because this is 15 plus 1 and 15 plus 1, right? I hope that I kind of threw that quickly at you, but that's essentially how you can kind of mental math it in your head. You could go, okay, I have 15 and 15 is 30, but you got to remember in your head that it's 2 16s, not 1 16. You have a 15 plus 1, and you have a 15 plus 1. So right here's the 2, right? That's where you get the 2 from. Therefore, our answer is 32 here. And if you know, hopefully you guys have been working on your integer grid. Do I have that opened? Well, let's see if I can find it here, integer grid. Give me a sec, guys. I thought I had it open, but I don't. Here we go. Okay. Close this, rotate this. So you guys could kind of screenshot this or use snipping tool, right? And then just kind of do that. then you could save it and then print it, and then just cut it in half if you want, and then connect the zeros. Okay, so anything to the right of 0 is all positive numbers. They're increasing positively in the right direction, and then turn any negative values increase. Technically speaking, they're increasing, but they're going left, right, in a negative direction. So here I have negative 26. So to get to 0, I need 26 positive jumps. I'm not counting these ones, but I need 26 jumps just to get to 0. So if you recall that in your head, you just kind of visualize, okay, I'm at negative 26. I need 26 jumps. Technically speaking, you're going to be going negative 26 plus 26. That's what it's going to be, right? Our answer is going to be 0, okay? I just wanted to kind of go over the integer grid quickly. Okay, we need 26 jumps, positive 26. Oh, goodness gracious. Just to get to 0. Okay, and anything extra will be in this. In turn, it's the same thing. If I'm here at positive 26 and I'm going 26, take away 26. Remember, guys, I didn't go over this, but if you've been following this series, you've heard me talk about the energy grid, and I've explained it quite a bit. Okay, this sign here belongs to this 26. This is an imaginary positive, right? We don't write it, but it's inferred positive, okay? This negative belongs to this. So this is actually negative 1 times 26, technically speaking. That's why the negative belongs to the 26, okay? So with that said, I'm going negative. When you're going negative, you're going to the left, okay? Negative, you go left. Positive, you go right. So I'm going 26 minus 26. So that means I'm going to be doing 26 negative jumps just to get to 0, okay? With that said, let's continue. Oh, goodness gracious. Okay. How are we doing for time here? I just want to make sure. Yeah, we're getting up there in time. Thank you to those that are watching. You guys are like pretty awesome people. You got to give yourself a pat on the back, because like, I won't lie, like I'm trying not to be negative here. I feel like, there's only so many people that are in the world that want to learn, especially nowadays. It's just, I don't know. I'm trying to not talk about other things, right? That's why I'm trying to stick talking about math. Okay, guys? But you guys are part of that. I don't know what the percentage of the world is that actually wants to learn. But you guys that are sitting here watching, you guys got to realize you're one of the beautiful, amazing, intelligent people in the world you're improving your mind, you're improving your knowledge, you're learning things that are actually, educational versus what everybody else, like, just stay away from I'm going to leave it at that. But you guys, I just want you to know how awesome you are watching. You guys truly are pretty amazing people, I'm telling you. Okay? All right. What are we working on? So there we go. So our answer essentially is going to end up being 0. So as you can see, if we're at negative 32, of course I don't have 32 here because I ran out of sheet space. But 32 is over here. So negative 32 would take me to 0, right? We all know this. If you have 36 apples and someone came and took your 36 apples, okay, you're the one that has education, right? You're the one with the 36 apples, and then you get some criminal garbage thief with no education comes, steals your 36 apples. Well, now you have 0, right? But you're still the better person anyways, okay? Just so you know. You're still better. Alright? Except, of course you don't have 36 apples, but, our Lord above will take care of you. Okay, let's continue. So that's done. So our answer is 0. Okay, so we have 3 cubed. Okay, so if you don't understand, we didn't really talk about exponents much, but really what an exponent is, guys and gals, it's not, I could write it like this as well. It means the same thing, okay? It also means this. It means the same number times the same number times the same number. 3 times, okay? 1, 2, and 3. Okay? That's what that means. So you're taking whatever number's inside and you're multiplying it to itself 3 times. Right? If this was a 4, then you would be doing it another time. Okay? That's exponents in a nutshell. Alright, so we have plus. Okay, remember addition, subtraction's last. So look, we have neighbor 1. We're going to call it neighbor 1. Okay, we have neighbor 1. I'm trying to write an N here. Okay, and so here's a fence here. That's going to be last anyways. We have a bracket, which makes this kind of easy. We know that we're going to be doing anything inside brackets first. So that's fine. And then we have, all of this, so is multiplied by 15. So what this means is 15 is going to be multiplied to everything that's inside the brackets. So I could go 15 times that, 15 times that. It still works the same way, but it's best to just do this calculation first, right? It's just less work for you later. And then we're going to finally end up with minus 21. So there we go. We have another neighbor. So we have neighbor 1, and we now have neighbor 2, and this is going to be neighbor 3. Okay? This is kind of a fence, okay? That's kind of what I'm trying to show you, the separation in parts. Break the problem into sections. Essentially, that's what I'm doing, guys and gals, okay? Whoops. I'll just rewrite it anyways. I just want to clear it up. Okay? Just so it doesn't look so messy and confusing. Okay, I want to make sure it's clear and concise for you guys. Minus 15. And then I'm just going to put the 15 here. It's still inferred. Anytime you, so the way they've written it, they've written times. It's not really necessary to do that. Anytime you have a number beside a set of brackets, that's already inferred multiplication. Okay? You don't need to write it. And then minus 21. Okay? There we go. So, I know this is neighbor 1. I know this is all neighbor 2. And I know this is neighbor 3. Okay? Break it into parts. So with that said, that means I could do this and this together at the same time. Okay, you don't have to go do this part, then write it all out again, and then do this part, then write it all out again. Just recall that these are all separated. Okay, again, addition, subtraction is last. So I could go 3 cubed. 3 times 3 is 9. 9 times 3 is 27. Plus, now I'm going to write it like this because I like to be organized. It doesn't matter if the 15's on this side or on this side. If you're still multiplying to something, you're still multiplying to something. It's all the same. Okay, so I'm going to do what's inside the brackets first. Okay, 25 take away 15, right? We know the answer, but we'll do it anyways. 5 and 5. If you have $5 and you gave somebody $5, you don't have any money left. You got 0 now. 2 take away 1 is 10. So we're here at 10. And then subtract 21. Okay? Remember, we haven't done anything with this yet. That's last. He's just hanging out, waiting. Again, make sure you don't forget to bring it, carry it down. Don't forget your parts, okay? This guy's just hanging out for now. We're still not done. I could have did everything all in one shot. I could have. But I'll show you the work. So let's continue. 27 plus. Okay, this is bracket stuff still, guys. Okay, still brackets. Okay, let's get rid of all the brackets. Let's get rid of them. So 15 times 10, right? We should know, guys, it's pretty straightforward math. Anytime you multiply, like 15 times 1 is 15, right? We don't need to do the long math. All you really need to do is just put the 0 behind. Okay? You could do the math in your head quickly. You could do the long math if you want. It's up to you. Right? You could. But anytime, like, it's the same as going 15 times 100, right? All I need to do is go 15 times 1 and just bring the zeros over. Done. It's that easy. Easy math. Okay, and then minus 21. Okay, so now we're done. We got no brackets. It's all done. Division, the multiplication. There was no division. The multiplication is done. So now we're down to part 3 of bed math, which is straight addition, subtraction. So this is going to increase, right? When we add two numbers together, we're increasing, right? This is a decrease. So however you want to do it is up to you. It doesn't really matter. You could do this first. It still all works out in the end, right? So let's just go 150 plus 27. We'll just do this part first. Little bit we'll do. So we're adding. Okay, again, it's adding. So 7, 5 and 2 is 7, 1. Okay, 177. So we're left with 177. Bring the 21 down. Okay, this part's done. Okay, we've done that right there. Okay, now let's finish up. 177. Take away 21. It's easy math because this number is greater than this bottom number. You don't have to borrow. As long as this number is greater than the bottom number, you don't need to borrow. Okay, 7 take away 1 is 6. 7 take away 2 is 5. And bring down the 1. So there's our answer. 156. Let's go. Drop the A's. Okay, how are we doing on time? We're getting up there. I'm gonna clean up this board here. We'll do a couple more, but we'll solve it in the next video. So I'm gonna write it down. You could practice it yourself if you like. With the little rules that I've given you. Okay, this one might be a little bit more challenging. We'll see. Okay, and this is actually written as a fraction, which is nice. Okay, that's it. It's actually not too bad. With the little tips and advice I've given you guys, you should be able to do this no problem. I believe in you. Okay? Again, you guys are part of the 120 IQ Club. Let's go. Support you in your journey in learning mathematics, because mathematics is fun. Let's go. Turn it up. Again, I appreciate you being here. Thank you, homeschooling parents, for having your child learn on the channel. Appreciate that. Again, just for you parents to know, if you've been following the video series, you'll know I'm sticking to the program, just talking about mathematics and mathematics only. I may go into, some short stories or whatever, but for the most part, I'm not really straying off topic, sticking to mathematics, and anything mathematics related, even the stories would be too. But I really don't talk much about stories anyways. I might give you an example of what happened when I was in college or something, right? But for the most part, I'm sticking to mathematics. Students, if you're looking for extra additional support, maybe your instructor isn't teaching mathematics and should be, here to help you learn, because you want to actually pass the class, right? Which is awesome. That makes you the better person as far as I'm concerned, because you actually want to learn to succeed and grow as an individual, which is awesome. It's awesome. All right, I will leave it at that, guys and gals. Appreciate being here. Johnny Whiskey Tango Sharp, doing lots of things over here because I love learning. And I'll see you guys in the next video. Take care for now, and peace.